All right, we are starting with the anti-differentiation, what we did in unit page 14, is that right? We start with the differentiation. So now we're going to do the anti-differentiation. In mathematics, we always have the backward process. So if you have your function fx and you're going to have your f prime x, if you go forward, that is your dy dx differentiation, and you go backward is anti-differentiation known as integral. Okay, log, anti-log, same in that manner. You plus, you go backward, you minus, you multiply, go backward is divide. Okay, so they're trying to show you the theory of it here. It is not necessary, they will not ask because most of you here are learning for marks. This kind of question will not come out, but nevertheless, let's go through. We know that if you have y equals to x cubed, if you differentiate it, you will get 3x squared. So that means you have your x cubed here. When you divide dx, you're going to get 3x squared. That is going forward. Coming backward will be the integral. Okay, so if you integrate 3x squared, you should be able to get x cubed. However, what if you have your x cubed plus 3? If you differentiate, you're still going to get 3x squared. And when you integrate back, you would not know whether it is from 3 or plus 5 or what. That's why we need to have what we call the plus the c. Okay, plus the c. Without the c is perfectly fine. I just minus 1 mark. Okay, if you don't put the c, minus 1 mark. If you have, sorry, the writing will take a while for it to be nicer because been a while resting. No plus c, you have minus 1 mark. Please put the plus c at all costs. Okay, so that's why you have the integral of 3x squared is x cubed plus c, although we know it is from x cubed. Okay, so when you go backward, you need to have the plus c. Okay, are we clear? So they can go, we can do this for all the others, and they try to prove you the formula. I'm not going to go through on this. If you want, you can look through this. I think this is a clear explanation how you get from your integration differentiation of n plus 1. How do you get this? And you integrate it back, you'll get back the things, the formula. So we're going to work only on the few here now, not all. First of all, I think what is missing, can I add in one more for you? If you have your y is equivalent to kx, okay, the dy dx is equivalent to k, okay, dy dx is equivalent to k. Therefore, you would know that the integral of k, every time you have the symbol of integral, you must have the dx. So the variable here is x. If you are doing it velocity, then it's dt because the variable is time. Okay, so that will give you kx plus c. Integral of a constant is kx plus c. Okay, example, what would be the integral of pi? Yes, Omar, right? Yeah. Yes, good. That gives you pi x plus c. Pi is just a number. Okay, pi is just a number, so it's a constant, so it's constant plus x. Sorry, constant times x plus c. Okay, so if you have just a polynomial a x power n, it is differentiation we minus, integration you plus. Can you see that? Differentiation you bring down the power, you multiply. Integration reverse, multiply means divide. Okay, so everything is reverse from the differentiation. So if you integrating x power n, that will be the formula, and most importantly the n cannot be -1. Okay, n cannot be -1. Example, if you're integrating 3x cubed, so 3 is coefficient. Do not worry about 3, just write the 3 there, don't bother about the 3. X cubed, 3 plus 1 is divided by 3 plus 1 plus your c. Are we good? Okay, I think most of you would have done at maths, you should know lah. The 3 go we will do it next week. 3 go we'll do next week. Next, this is so not nice. Next, I will write it here. If you're integrating, can I just put an m in front instead of that? No m, and then a ax plus b power to the n. M is the coefficient, just for you to know what are we talking about. Example, you may have, for example, integral -5 2 minus 3x power to the 4. Example. Okay. On the left side is the formula, right side is the example. For the formula is m is always doesn't bother anybody. So just put it, just put the m there. You're gonna get that ax plus b power to the n plus 1 divided by the coefficient of your x, which is a, multiplied by the power n plus 1 plus the c. Are we good here? Okay, so can we look at the example then? -5 is -5, 2 -3x 4 plus 1 is 5 divided by, what is the coefficient of your x? Coefficient of your x is, excellent, times by 5 plus your c. Always give your answer in simplest form. That will give you 1 over 3 2 minus 3x power 5 plus c. Are we okay, people? Okay, so we're gonna do until here only for the day. The rest is going to be practice, but you got to be careful here. There are a few things have to be. Why there's a pen color limited? Okay, you have to be mindful here. First of all, is only for linear factor. This must be linear. That's what I meant. If that is not linear, then you are doomed. Must be linear. Those who are doing advanced maths, you probably can do non-linear lah. Anybody doing advanced maths? Yeah, so you probably can. Second limitation, your n cannot be -1. When n is -1, we got different formula. You got to keep in your mind these two limitation. First is only for linear, ax plus b. Only for ax plus b. Next, the n cannot be -1. Can -2? Can. Only cannot be -1. That's my cursor. Are you guys okay? All right, can we look at exercise 6? Why is it cursor not coming out? All right, can we do number 1? For each of the following, find the antiderivative. Here is quite important for you to know. There are, if you look at it, there are three different things. If you are given fx, if you're integrating fx dx, it gives you capital F plus c. If you are integrating dy dx, actually times by dx, normally we don't write like this. The dx and dx can be cancelled. That gives you y plus c. And if you are integrating f prime x dx, that gives you fx plus c. Notation. For you, it may look the same. They're all different. If you're integrating f, capital F. If you're integrating f prime, is small f. Okay? Okay, just give me a moment. How do I stop this?